So we start off with trigonometry. So what is trigonometry? Trigonometry is a branch of mathematics that studies relationship between sides, length and angles of a triangle. So here now metry means measurement, trigno means triangle. So trigonometry is branch of mathematics that deals with finding measurements of angles and sides of a triangle. So let me take so first let's start off with a right angle triangle over here. So if I take a right angle triangle, okay, let me name this as ABC. A right angle triangle is a triangle in which one of the angles is 90 degree. The side opposite to 90 degree is called as the hypotenuse. Okay. Now, if I consider an angle over here, let's say this angle over here, and I will call this as theta. Now, with respect to theta, this is the side opposite to theta, therefore, this is the opposite side. Now, as far as theta is concerned, it has two adjacent sides over here, BC and AC. But since AC is the hypotenuse, here side BC would be called as the adjacent side over here. Now, when it comes to trigonometric ratios, there are six main trigonometric ratios. There are six trigonometric ratios. One is sine theta, which stands for opposite side by the hypotenuse. Now, in this case, opposite T over there, opposite side over here is AB. AB by the hypotenuse, that is AC over here. Then cos theta stands for adjacent side by the hypotenuse. So adjacent side over here with respect to this angle, that is theta, is BC. BC by the hypotenuse, that is AC. Then is tan theta. Tan theta is opposite side by the adjacent side. Now opposite side to, see, it is tan of angle theta. The opposite side over here is AB and the adjacent side is BC. Now the other trigonometric ratios are reciprocals of these. So the first reciprocal, that is the reciprocal of sine theta, is given as cosec theta. Since it's reciprocal, it is 1 by sine theta. Okay, and here it is opposite by hypotenuse, it would become hypotenuse by opposite. And it would be what? It is AB by AC over here. This would become AC by AB, reciprocal. Now, reciprocal of cos is sec theta. Sec theta is given by 1 by cos theta. Since it's reciprocal, it is hypotenuse by the adjacent side. Hypotenuse is AC by BC. Okay. Reciprocal of tan theta is cot theta, which is adjacent by the opposite. Is the reciprocal. So therefore it is BC by AB. So these are the six trigonometric ratios. Sine theta, which is opposite by hypotenuse, cos theta, which is adjacent by hypotenuse, tan theta, opposite by adjacent, cosec, reciprocal of sine, it is hypotenuse by opposite, sec, it is reciprocal of cos, it is hypotenuse by adjacent, cot is reciprocal of tan, that is it is 1 by tan theta, it is adjacent by opposite, which is BC by AB. Let's see one more example. Let me take one more triangle. I'll call it as DEF. DEF. Okay. This will be my 90 degree. Let angle E be equal to 90 degree. And here I will take F as theta. Now, the side opposite 90 is your hypotenuse. Adjacent is next to. Adjacent means next to. So there are two sides that are next to, that is FD and FE. But FD is your hypotenuse, so FE becomes your adjacent side. And the side opposite to theta is your opposite side. Okay. Now, again let's consider our trigonometric ratios. So sine theta in this case, I know sine theta is opposite by the hypotenuse. Opposite to this is DE. and hypotenuse here is FD. Cos theta is what? Adjacent by hypotenuse. Adjacent here to this angle theta is FE by the hypotenuse, that is FD. Tan theta. Tan theta is given by opposite by adjacent. Opposite in this case is DE by the adjacent is FE. Now, cosec theta is reciprocal. It's 1 by sin theta and it is what? Hypotenuse by opposite. So it is FD by DE. Then reciprocal of cos is sec theta, which is 1 by cos theta. Reciprocal. So hypotenuse comes to the numerator and adjacent comes to the denominator. So it is hypotenuse by adjacent. So it is FD by FE. Then reciprocal of tan is cot theta. It is 1 by tan theta. So it is opposite by adjacent. This will become adjacent by opposite. So this will be FE by D. Now let's look at exercise 8.1. It is given in the triangle ABC, right angled at B. So I'm talking about the first one here. I have a triangle ABC, right angled at B. So B is 90 degrees. So I have ABC. It is given to me. AB is 24 centimeter and BC is given as 7 centimeter. Determine. So what do I have to find? So let's write down. To find is what? To find sin A, cos A, then I need to find sin C and I need to find cos C. Okay, so the angle here is angle A in the first case. So let's just consider the first case. Can I first we'll just finish this Pythagoras theorem. So I have to, Pythagoras theorem is what? The hypotenuse square of the hypotenuse is equal to the sum of the squares of the opposite side. So I have AB, sum of the other two sides, squares of the other two sides. So it is AB square plus BC square. So can I have this as x? So x square is equal to 24 square plus 7 square. So 24 square is 576. 7 square is 49. Which is equal to 625. So x would be square root of this, which is 25. So this side is equal to 25 centimeter. Sin A. So sin A. Sine of angle A. So side opposite to angle A. Side opposite to angle A is BC. By the hypotenuse, that is AC. So that is 7 by 25. See, ratios never have any units because when I'm talking about ratios, the units have to be same so that they cancel out. Ratio doesn't have any unit. Cos A. So it is, I know, adjacent by the hypotenuse. Adjacent to what? Adjacent side to angle A. So this is my angle of reference. So this is the side adjacent. So that would be 24 by 25. Now when I'm talking about sin C, I have sin C. I know sin is what? Opposite by the hypotenuse. Opposite to what? Angle C. So this is angle C. The side opposite to angle C is AB. AB by the hypotenuse is AC. So it would be 24 by 25. Then our required is cos C. Cos C. It is adjacent by the hypotenuse. Adjacent to what? Angle C. This is my angle C. So the adjacent here is 7. By the hypotenuse, that is 25. So those are our answers. So that's our sine A, this is our cos A, this is our sine C, and this is our cos C. So the second one, in the given figure, find tan A minus cot R. So what is the given figure? The given figure is triangle PQR. So the given figure is triangle PQR. So I have triangle PQR. Okay. I have PQ as 12 centimeter. We have PR as 13 centimeter. So QR we are required to find, but first let's write down what are we supposed to find. So we are required to find tan P minus cot R. Okay, so I need to find QR. Again, using Pythagoras theorem, I have PR square, hypotenuse square is equal to the sum of the squares of the other two sides. So it's PQ square plus QR the whole square. I'm interested in QR, so I'll shift PQ to the other side. So PR square minus PQ square is equal to QR square. Now we know this is of what form? It is A square minus B square, which is A minus B into A plus B. This actually makes our work easy most of the time. So PR is 13 minus PQ, that is 12. So that became 1. And here I have, sorry, it's plus. So it's 13 plus 12 equal to QR square. So this is nothing but 25. So square root of 25 would be, and this is 1. So 1 into 25 is 25, would be QR, and that is 5. Since all are centimeter, this would also be centimeter. Okay. Now, our required is tan P minus cot R. So first let's find out tan P. What is tan P? Opposite by the adjacent. Opposite and adjacent to what? Angle P. So opposite to angle P would be QR. If you see here, it's QR, by adjacent to angle P would be PQ, which is, sorry, I should write here PQ. So that would be 5 by 12. Then cot R. Cot is given as adjacent by opposite. Adjacent and opposite to which angle? Angle R. So adjacent to angle R is 5 centimeter, that is QR. Okay, and opposite to angle R is PQ, that is 5 by 12. Now I have this tan P is 5 by 12 and cot R is also 5 by 12. So 5 by 12 minus 5 by 12 is 0. Okay, this is the next question. If sine A is 3 by 4, so this is a ratio that's given. So I don't have any centimeter or meter or anything. I don't have any unit here because it's a ratio. Sine A is 3 by 4. Calculate cos A and tan A. So let's take a triangle. Now since it's not given to us, I can only angle A is given to me. I can name this as B and C. So when I'm talking about sine A, so this is my 90 degrees. Sine A, what is sine A? Is opposite by the hypotenuse. So it is 3 by 4. See, how do we get ratios? Now for example, if I have 10 by 20, when I am dividing, if I am asking you to find the ratio is always in the simplest form. So you would divide this by 10, both the numerator and denominator, by the highest common factor to get the ratio. That's 1 by 12. So if I am multiplying back by my highest common factor into 10 over here, I would again get back my original values. So similarly over here, sine A is a ratio that you have. So what can be the original? I don't know what the HCF is. They have been divided to get the ratio. So I can say let the HCF be X. So now the original sides are 3 and 4. The ratio of sine A is 3 by 4. So the side opposite to angle A is 3x and the hypotenuse would be 4x. Now I have to find BA. So according to our Pythagoras theorem, AC square is equal to BC square plus AB square. I don't know BC, so I'll shift I don't know AB, I'll shift BC to the other side. So AC square minus BC square equal to AB square. As I said, A square minus B square is A plus B into A minus B. So I have AC is 4x plus BC, that's 3x. 4x minus 3x equal to AB square. So over here we have 7x. This would be 1x. Over here, I think I made a mistake. No, I did not. So over here we have 7x. So what is 7x into, this is just x. So that's 7x square. 7x into x is 7x square. That's AB square. AB would be root of this, which is root 7x. So this is root 7x. Now what is our requirement over here? Our requirement is to find cos A and tan of A. So cos A. Cos is given by adjacent by the hypotenuse. Adjacent to which angle? Angle A. So that's side AB. And the hypotenuse is AC. So it is root 7x by AC, that's 4x, gets cancelled, root 7 by 4. And then we have tan A. Tan is given as opposite by the adjacent. Adjacent, neighboring. So all this to with respect to which angle? Angle A. So opposite to angle A is 3x. 3x by adjacent, root 7x. So I have, it is 3 by root 7. So those are our required angles. So we'll stop it here for today. We'll continue the rest tomorrow or the next video. Thank you.